Okay, yeah. Particular a steel aircraft is 370 meter long, so its length is 370 meters. When moving through an icy North Atlantic at the temperature of, so the temperature initially was 2 degrees Celsius. By how much does the carrier lengthen? So when the change in length of the carrier, when it is traveling over the warm Mediterranean Sea, that has a temperature of 21 degrees Celsius. So basically, we want to see how will the length change from this one to the final length. How will the length change? When the change in length, basically, comparing it when it's traveling at 2 degrees and 21 degrees. So this one is very simple. So its change in length is equal to LO alpha change in T. Our LO is 370. U-alpha-ke sikhuluma nge-steel. So let us see if we can find alpha for steel. Alpha for steel is iron. Oh, it's 12. It's 12 times 10 to the minus 6. And then the change in temperature is 21 minus 2. Okay, let me punch the calculator here with you here. It's gonna be a long video. If you want the answers, you can like fast forward it or go in 3 times. So that is okay, because it's very, very long. Uh, yeah, so Lana, it would be 21 minus 2. 21 minus 2. When I get 0.084. 84 meters. So that's the change in length of the steel. Then we move on to number 12. Batila, a rod made from a particular alloy is heated from its initial temperature is 25 degrees Celsius to the boiling point of water. So its final temperature is 100 degrees Celsius. Its length increased by, it gave you the change of length to be 8.47 times 10 to the minus 4 meters. Then they say the rod is then cooled from a temperature of 25, again from 25 degrees Celsius to the freezing point of water, which is 0 degrees Celsius. But by how much does the rod shrink? So for now, how much will it shrink? So this is clearly an example to show you which when the temperature increases, the length will increase, or it will expand. Then when the temperature decreases, from 25 to 0, the length decreases. Another change in length, I'm question to shrink. Just calculate how much it will shrink and not expand, even though the topic is thermal expansion. So Lana is pretty standard that you can use all the information to find which is because they didn't tell you which metal you are working with, but a particular alloy. So since it's a particular alloy, it means you don't know alpha or corner. And to calculate a change in length, like the name, you need alpha, LO, change in T now I change in temperature. So you have change in T, but LO and alpha are none. You can use the first information to find LO and alpha. So So the final temperature here is 0. So using the first information, we can say change in L is equals to LO alpha change in T. The first information, the air change in L was 8,47 times 10 to the minus 4. And then LO was, you don't know LO in alpha it. So LO alpha was, but your change in T was 100 minus 25, which was 75. Sorry, let me rewrite my alpha here. So, but you can figure out that LO alpha is equals to 8,47 times 10 to the minus 4 over 75, and yeah, that's your LO alpha. So when you punch in a calculator here, it's say 8,47 times 10 to the minus 4, and it's over 75. I get to be 1.1 times 10 to the minus 6, minus 5, minus 6, yeah. Yeah, so that's your NO alpha. You can use this in the second data to find your change in alpha, voila. So now you can say for the second part, change in alpha is equals to LO alpha. Why alpha more X? I don't know what's wrong with me. My alpha is X. Change in T and it. So to find the change in length is 2, we just substitute 1,1 times 10 to the minus 6 here, multiplied by the change in temperature. Now it's from 25 to 0, and so 0 minus 25. And the negative change in length means decreasing length. So 1.1 times 10 to the minus 6, and times negative 25. Oh, now I get minus 2.7 times 10 to the minus 6. Yeah, meters. So it shrinks by 2.7 times 10 to the minus 6 meters. The negative change in length means shrink. Change in length or positive because it expanded, because temperature increased. Temperature increases, the length increases. But here, the temperature decrease means the length decrease. So yeah, moving on. Number 13. That's the length of each edge of an aluminum cube is, so the edge length is 0.05 meters. The cube is heated to, so its final temperature is 145 degrees Celsius, and its initial temperature is 25 degrees Celsius. What is the increase in the surface area on the cube? So when they change in the area, I think we did something like this before. Yeah, it's an aluminum cube foot on it. So siyazi sikhuluma aluminium na. So alpha aluminium 125 times 10 to the minus 6. I think confirm that. Aluminum, yeah, it's 25 times 10 to the minus 6 lah. So it's funny change in area, but we must first find the original area in it. The original area is 6L squared. That's how we calculate the area of a cube. So when we function a calculator now, you can see what we get. 6 times 0.05 squared. So this is 0.015 meters squared. So the change in area is the original area times 2 alpha change in T and it. So it's 0.015 times 2 times 25 times 10 to the minus 6. And the change in T is 145 minus 25. So when you punch in a calculator, 0.15 times 2 times 25 times 10 to the minus 6 ish. Yes, and then it's 145 minus 25. Make it to 0.00009 meters squared, which would be 9 times 10 to the minus. More enough? Funny? Mike? Oh, okay, it's a full mic. I want to be actually. Hey, I talk was loud and don't talk up. Hey, loud. Come up, it's it. It's also was, bro. Come up. Hey, it's not. It's a bean. Yeah, I'm picking up my game now. Fixes yeah. I'm gonna find machine in the past. The way you mean. Uh as we're saying that that's how we're gonna find the area. And then number 14. Fertilizer swimming pool contains that's volume volume 110 meter cubed of water. The sun hits the water from initial temperature of 17 degrees Celsius, final temperature of 27 degrees Celsius. What is the change of the volume of water? So this one is very easy. We just need the OP. Let's see what man. We just need the one for man just that. Uh, Look, I'm going to that knife. What is that? Hold on. I'm going to go out there for someone down. Text. Hey, you go to the I'm not guys. Go to the nine now. Come on. I'm still scared. No, but yeah, so for amanzi awanawo alpha no-B because asifana ngokwe-volume vele yabo. Nala vele sisebenzisa le formula le-volume le lithi yeah, so to find the change in volume, the original volume was 110. V is 210 times 10 to the minus 6 for water. Change in T now is 27 minus 17. Answer here would be 0.231 meter cubed. So yeah, uyenza kanjalo number 14. Then number 15, but the air inside a car has a mass of 2.6 kilograms and a specific capacity of 120 joules per kilogram Celsius degree. The driver loses heat at a rate of, so heat rate 120 joules per second. But if all the heat goes into increasing the air temperature, how long does it take the temperature to change from the temperature change 37 minus 21, which is still, yeah. So let us finish cards. Finish cards. To find the time, before the next card, as I told you, it's heat transfer the heat over the time. So first we must find the heat. Now I'm going to reach for the card. So the heat needed now will be specific heat for the temperature change. It's the mass times C times T. The mass of the air is 2.6, E is 720, and changing T is 16. So get a heat liner of 29,962 joules. And then now that we have the heat, we can say the heat transfer is the heat over time. The heat transfer is 120, and the heat is 29,952 over the time. So the time it will take would be it would be 29,952 over 120. So that is 249.6 seconds, which is yeah, the converter to minutes, but now answer. Yeah, 250 seconds. Divide by 60 that for 2 minutes. But yeah, that's your answer there. Number 1, 15. And then we have number 16. It's 1 gallon. So 1 gallon, you say as 1 gallon being equals to 3 times 785 times 10 to the minus 3 meter cubed of water is at, so initial temperature 25 degrees Celsius. Is placed in a refrigerator to make ice water. Okay. So by efrijini ukuthi lose heat izoba i-ice angithi. How much heat must the refrigerator remove from the water to cool it to? So if final temperature siyazi ukuthi 5 degrees Celsius. Lana bathi how much heat must the refrigerator remove? Okay, so sifuna heat lost la. And the heat lost izophoza ne-change of phase angithi ukubona lo. But is placed to make ice water. Oh, it will not cause ice angeke ibe khona, but it would be ice water. Amanzi abanda kakhulu lawo. Because aku-5 degrees, awafika ku-0 ukuthi abe i-ice. So the heat loss will only cause a temperature change, not a phase change. If there was a phase change, the calculator no latent heat, but we don't in this case. So lana basiniki volume. This is volume, yabo. It's not mass. So now masifuna heat loss yazi ukuthi it's the mass times C. C is now changing T is now shorter than mass. First, we must calculate the mass of the water. Giving a volume, we know which density is mass over volume, and its density of water is 1000. The mass on volume is 3.785 times 10 to the minus 3. Let's figure out the mass. The mass here, it should be okay, let me punch in the calculator here. So mass 1000 times 3.785 times 10 to the minus 3. So the mass is 3.785 kilogram. So it's 3.785 times zero corner. See what math is that 4186, and change it here, it's 5 minus 45. So the heat that must be lost is 3.785 times 4186 times negative 20. So it's about minus 31688 0.2 joules of heat that must be lost. And it makes sense depending on this mass of the water. So the fridge must remove this amount of heat to change this water to ice. So yeah, that was number 16. These are very easy matter to pay. They are easy. Goods in very, very many of them. But let's continue and see if it's put it up. It's still recording. Right. Number 17. Number 17, but a brass bar and an aluminum bar are in the drawing are attached to an immovable wall. Okay, so we have brass and we have aluminum. For the brass, original length of the brass is 2 meters. The original length of the aluminum is 1 meter. The initial temperature allowed 22 degrees Celsius. Initial temperature allowed 22 degrees Celsius. The air gap between the rods is, for this gap, length the gap layer. At what temperature would the gap close? Okay, this one is very easy. Ukuthi nje funa ukuyicabanga. Bambana le aluminum nale brass kuya-expanda ngithi. So baku-expanda, i-brass izoya le, aluminum izoya le, until this gap closes ngithi. So do you see ukuthi angithatha change of length of the brass, which would be how much would the brass expand towards the right, plus the change in length of the aluminum, meaning that's how much would the aluminum change its length to the left. Konke kuzolingana nale size of the gap because kuzohlangana khona kuzoba 1.8 times 10 to the minus 3 meters. Mangithatha change in length of the brass plus change in length of the aluminum. Yeah. So that's your equation here. Also, you have to understand that the gap will only close when the brass and the aluminium have changed their length to the final temperature. So change in length for the brass plus change in length for the aluminium is equal to the gap. Only the change in length. So okay, change in length of the brass would be original length of the brass, alpha for brass, change in temperature. The aluminium aluminium alpha change in temperature is 1.8 times 10 to the minus 3. The original length A plus 2. Alpha plus so there alpha plus 19 times 10 to the minus 6. Change in T. Change in T, okay, final temperature here is initial temperature 22. Plus, sesifaka aluminium-ke manje, original length was 1. Alpha aluminium sesiyawazi by now, it's 25 times 10 to the minus 6. And then the final temperature minus 22 now. All of this is equals to 1.8 times 10 to the minus 3. And you solve for the final temperature. ايش هو انا مش هاي complete لا but let us see. Oh, it's easy, it's easy. First it's gonna be it's going to be the passes about 1.8 times 10 to the minus 3 over this 2. 2 times 19 times 10 to the minus 6. And it's 25 times 10 to the minus 6. Yeah, and then the answer is so plus 22 on it. So 50,57 answer yakho. That's your final temperature. Uh, where the gap will close. So by 18, but a woman finds a front shield of a car covered with ice so we have ice at a temperature of minus 10 degrees Celsius. Ice has a thickness of the ice is 5 times 10 to the minus 4 meters. And the windshield has the area of the ice is 1.1 meters squared. And then they say the density of ice is 917. Density ice 917 kilogram per meter cubed. And how much heat is required to melt the ice? Now calculate the heat to melt the ice. So again, now you take the perspective of the ice affairs. What will happen to the ice level? So wait. Let's play ice in the magic to the weather region. The ice layer is what -10, right? So the total heat required to melt the ice is the specific heat so far so we saw from -10 to 0, right? And then plus the latent heat to change its phase. So that's all the heat there is to melt this ice. So specific heat is the mass times specific capacity times change in T, right? In this case, the heat is being gained by the ice to melt. It's plus mass times LF. The ice must gain heat, so we have no positive. So sesiyabheka-ke yini esinganayo? Asinayo i-mass of the ice ayetholile. Siqale sithole i-mass, sinikwe i-density. We know that density is mass over volume, right? But first, we must find the volume. Now, do you see these two units, meter and meter squared? When you multiply them, you get meter cubed, which is volume, right? So the volume will be the area times the thickness. So it's meter squared times meter. So Lana, it will be 1.1 times 5 times 10 to the minus 4. That's where you're going to find the volume. So the volume is 1.1 times 5. Wait, which I have to calculate. 5 times 10 to the minus 4. So this is like 0.00055 meter cubed. That's your volume then. Mass total volume, you then say density is equals to mass over volume. Density of ice is 917. When the mass of the ice, the volume is 0.00055. So what would be the mass of the ice? 917 times 0.00055. Should be 0.5. 0.3. 5.1. Not 5.1. 5.4. Yeah, 0.5. Now we have the mass of the ice. Let's see where ice is now from tables, the change in temperature. We know it's from -10 to 0, and so it's now changing T is now LFS per day. So total heat is MC changing T plus MLF. M was 0.5. Let's see where ice is 1. 2100, just 3. 3 for ice is 2100. So changing T 0 minus initial, which was -10. And then we have 0.5 times, that's any confusion, no? Water is it's 3.33 times 10 to the 5. So the total heat would be 4.5 times 2100 times 10 like 0.5 times 3.23 times 10 to the power 5. So the heat would be 177,000 joules. That's the total heat required to melt the ice. You need this amount of heat to melt the ice. Because to melt the ice, you must first change its temperature and change its phase. Okay, number 1, look. 18. Let's try number 19.